The second part of chapter 28 deal with measures of these discrete random variables. So we're talking mean, standard deviation. X sub I in these formulas stands for the values that the random variable can take on, and F sub I are the associated frequencies. So here are two formulas that you might want. However, there are some shorter ones. And we're going to prove right now that the mean can also be found by taking X sub I times the probability of each event. So we're going to say that n is the sum of all these frequencies, just to simplify matters a little bit. And using the definition, the formula from the previous slide, the frequency times each value of the discrete random variable are multiplied together and added. And then we divide by the sum of the frequencies. And we can split this up into a bunch of fractions. Each frequency divided by n. Well, a frequency divided by how many things there are, that's just the probability of each event. So a much shorter formula is the value of the discrete random variable times its probability. All of those added up give us the mean. And there's another shorter formula for standard deviation too. And mean, if you notice, is the same thing as expected value. And then sigma squared, the variance, is also the expected value of our random variable minus the mean squared. Another notation is variance of x. Or a shorter formula than the one on the second line down is this one, because we only subtract the mean once as opposed to subtracting it from each data value. So we want to find the mean and the standard deviation. Why don't you pause the video here and do these two calculations. Okay, so you should have the calculations done. Let's see if you did them right. The mean is going to be each x times its probability, so 0 plus 0.23 times 1 plus 0.38 times 2 plus 0.21 times 3 plus 0.13 times 4 plus 0.05 times 5. And doing this calculation, we end up with 2.39 for the mean, which is also the expected value for our probability distribution. And then to find the standard deviation, we're going to take the square root of the variance, which was the probabilities times the random variable squared, and then minus the mean squared. And in doing this calculation, you should have ended up with 1.122. Find the mean and standard deviation of rolling a die. Well, the outcomes, different values for x, are 1, 2, 3, 4, 5, and 6, and the probability of each of them is just 1/6. So the mean is going to be the sum of these values times their probabilities, and since the probabilities are all the same, so 3.5 is the mean. The standard deviation, can be found by this formula, which is approximately 2.92. Here we have a probability distribution, and we want to know the median and the mode. And what we can do with this is we can think about what kind of frequencies we would expect from 100 trials based on this information. So essentially we can build a frequency table out of this. So I'm just going to extend my table. So the probability of getting a 0 is 0. That means we would expect 0 zeros. We'd expect 23 ones, 38 twos, 21 threes, 13 fours, and 5 fives. The mode is the thing that happens the most. So the mode is 2. The median is, out of 100 trials, there's going to be 2 middle numbers. It's the 50th value for x plus the 51st value of x divided by 2. And if we start counting here, we have 23 things in the first category. That's going to put both the 50th and the 51st smallest numbers into this 2 category. So we're left with 2 plus 2 divided by 2. So the median is also 2 here. Here are some properties for expected value and variance. Let's find the mean, variance, and standard deviation for this probability distribution. The mean, also known as expected value, is going to be 0.1 plus 2 times 0.3 plus 3 times 0.4 plus 4 times 0.2. And this is equal to 2.7. The variance of our random variable also equal to the expected value of x squared minus the mean squared. So 0.1 plus 4 times 0.3, remember x squared, plus 9 times 0.4 plus 16 times 0.2 minus the mean squared. And this is equal to approximately 0.81. And so the standard deviation is equal to the square root of that. So the standard deviation is approximately 0.9. Here's 2 more properties, and these relate to what happens when we multiply and add constants to our random variable. So here we have a random variable that's distributed that has a mean of 8.1 and a standard deviation of 2.37. If a new distribution is found by multiplying our random variable by 4 and then subtracting 7, what is the new mean and new standard deviation? We can use these 2 properties to figure that out. Remember, mean is the same thing as expected value. So we take 4 times the expected value, the mean of the original distribution, and subtract 7. So our new expected value, or new mean, for this y distribution is 25.4. The variance of y is equal to, it says a squared times the variance of x. So 4 squared times the variance of x, which was 2.37. So our new variance for y is somewhere around 81, but really we want the standard deviation for this problem, so that is the square root of our variance. We end up with 9.48 as the standard deviation for our new y distribution. Here is the assignment for the second piece of chapter 28.